Condensation.
Condensation.
Condensation makes it rain.
Look at the glass next time you drink your milk. Does it seem to sweat? Well, the glass isn't really sweating, of course, but it is wet. It's just the water vapor in the nearby air being condensed.
But can you truly describe why it happens? This is the question that the Flying Sharks had. We created and implemented a research project to help us understand people's understanding with this common phenomena. To begin, we interviewed 12 individuals to gauge their understanding.
Water and ice.
Water. Water.
Ice water.
It looks like ice and water.
Water. It's clear. I tasted it already. I'm pretty confident it's water.
Like water on the outside also?
Is it juice?
No.
What kind of liquid is that?
It's water.
I don't know what the actual terminology of that is. I want to say dew, but it's the reason I have a beer koozie. It's wetness, also water.
Condensation.
Some water.
Condensation.
Because it's cold and there's ice in it, and the ice melts and it kind of goes through the glass. You put too much water in there, now the water's on there.
Because the liquid inside the glass is colder than the glass itself.
Can you elaborate on that, like where it may have come from?
I cannot.
Temperature of the water, it's cold and it condenses, which I'm not exactly sure what that process is. I'm not exactly sure how, but it pulls the water or the moisture out of the air onto the outside of the glass.
The warm air with the cold liquid.
Why do you need the warm air?
I don't know.
I think it came from the coldness of the cup. That it's frost.
The water leaps out of the glass and goes to the outside.
The water in the air.
The water in the air.
Condense because of the cold temperature of the water inside the glass.
It's Gosling Diet Ginger Beer, all natural flavor.
Pop!
A fine Pilsner.
Happiness.
It looks like condensation.
Because it's made with lots of pop, and it got more pop on.
Taste the liquid on the outside. Does it pop?
It's water. A little bit of frost too.
Water as well.
Once again, a cold bottle in a humid air.
Is it any different? The same?
The same.
From moisture in the air around the can would be my guess.
I would think it's still the same. You still have a colder liquid on the inside than what the air temperature is on the outside.
The outside is warmer than the inside of the stuff. So it causes this dew on the outside. You should have had a Mountain Dew, then I could say the dew on the dew.
Oh,
but I can't think of the term. And it's killing me.
Until the water warms up.
Oh, probably till the temperature of the glass or the bottles gets down to, or up to the temperature of the air.
Once the liquid inside the glass started to equalize with the outside air temperature, then there would be less condensation forming.
If there's no coldness inside of it, then no frost would come. No, because there's nothing cold for the air to hit, and so it wouldn't happen. I don't know. There's, I think, 4 stages.
Okay.
So it all starts out on the ground, and then it evaporates, it collects in the clouds, and then it comes down, and it keeps on going.
There's a cloud, there's rain, there's a lake, there's evaporation, and cloud.
Where's the condensation part of the water cycle at?
I don't know.
You just remember the term?
Yeah.
So I know there's a bunch of different phases, including condensation, evaporation, transpiration, many ways that it goes from being in the oceans and lakes to evaporating into clouds, and then from there it precipitation also brings it back down to the oceans and lakes and rivers.
There were a few interesting findings that stuck out to us when we analyzed our interviews. First, there was differences between varying age groups of interviewees and their stages of cognitive development. The younger interviewees were more concrete in their thinking and answers. They were unable to reason abstractly. This was evident in misconceptions of where the water on the outside of the can and glass came from. This shows pre-operational to concrete operational development. Second, the water cycle seemed very disconnected for interviewees. There was a limited connection between the condensation phenomenon on the glass with how it relates to the water cycle process. Also, a majority of the interviewees remembered the term condensation and explained it with concrete ideas like warm air in a cold glass. A majority knew the water came from outside the glass and even used the term water vapor. But no one could really explain how the process happened. Instead, they listed what was needed for condensation to occur. We needed to find out why this was happening. So we took a trip to consult with an expert. We went to the Create for STEM Institute to talk with Kristen Mayer. She is a grad student in curriculum and instruction with a specialization in science education. We were hoping she could shed some light on why our interviewees could not explain condensation.
I think we don't do a very good job, and myself included, of helping students understand the role of energy in the process. Is something that I think kind of gets skimmed over a lot until you get to physics, and it's like, oh, the physics teacher will deal with energy. But not everyone takes physics, and even if they get energy in physics, they may not realize how it applies to these ideas they learned in like earth science or chemistry.
And she was absolutely right. Not a single person mentioned energy is transferred from hot objects to cold objects. Energy or heat transfer. It can be a very complex topic. Not a single person mentioned that.
Oftentimes in school, vocabulary and like learning, like memorizing things is emphasized, and you can, fill in the blank on the test. The word is condensation. I think if we introduce the term condensation too early, students latch on to that word and think they know the answer because they know that word is what I should say. But they don't understand what that word means.
Most of the people that we interviewed used the word condensation. Do you remember this guy?
I can't think of the term that's bothering me. If I could think of the word, then I could explain it. But without having the word, I cannot do it.
He was so hung up on not remembering what this specific word was that he said he couldn't explain anything. The crazy thing was, when we asked at the end of the interviews, how do you think your understanding was correct or incorrect, almost every single person said that they had a good understanding.
I think that I got it right in my head. I'm confident after what you said that you and I were thinking the same thing, but I don't know if I said it.
It was tougher for you to explain it.
Correct, because I didn't know the terminology. You're explaining it to me as if I got it wrong.
Fairly close.
Where do you think it was off since you said fairly?
Well, I didn't exactly mention that it was the heat transfer, and
since I brought that up, does that ring a bell now that you had talked about that in school?
Mm-hmm. Yes, we had.
Somewhat. I mean, it's not the fine details and all the exact terminology.
Somewhat close. I guess I didn't take into effect like the warmer air on the outside is what's doing the effect. I think of it as the cold ice on the inside making the effect.
That's mind-blowing since nobody actually could explain why it occurred.
While doing our interviews, we noticed many people were using the word condensation, but many could not really explain it in detail. Knowing a word but not its full meaning is a form of shallow understanding. It condenses, but I really don't know how that works, said one of our interviewees, proving that knowing a word is useless unless you can fully describe it and its application. Another example was getting hung up on terms, like another interviewee, which ended up hindering his ability to explain the process because he could not remember the correct term. He came close to having a basic explanation, but ended up holding himself back by returning to trying to remember the forgotten term.
Knowing, but not really knowing, the word was the most frequently seen occurrence of shallow memory. Another common occurrence we saw was interviewees creating a circle with their hands while describing the water process. This is a form of rote memorization, which is using mnemonics to remember simple information, but this too only applies to a shallow understanding. They learned the word, but not its real application. This shallow understanding is paired with fantasia, where the interviewees thought that they had a complete or deep understanding of the water cycle and its applications, but only really were scratching the surface.
Science. Condensation.
Oh.
Does that ring a bell now?
Yeah, that's what it is. Yeah.
Okay.
Yeah. Julia might even know.
She might.
That'd be sad.